We were doing NLP implementation.
Okay. Just launch a, I mean, just open a previous notebook itself. We'll continue in the same. I've uploaded the notebook now. 47, yeah. I hope my screen is visible. So we were discussing about NLP pre-processing techniques. So if you are presenting project to your, in your college, so many of the people have not documented clearly the insights and all, headings, insights of every graph, so results of every algorithm. So make sure you make a note of it. Okay. And write the conclusion results, like what did you understand from the entire project. It becomes easy for you to explain in a project explanation. Otherwise, you will struggle. People will ask you. Okay, so we're done till, okay, importing libraries. No, this, oh, sorry. I opened a wrong one, I guess. Just a minute. Didn't I upload notebook yesterday? I don't know what naming I gave. NLP pre-processing. Maybe this, yeah. All right, so we just imported regular expression string and we started with simple text and we did all the basic data cleaning process. Imported NLTK, natural language uh, related library, and then we performed the tokenization, word tokenization, sentence tokenization, and then we removed the stopwords, and then we did stemming, and then we did post tagging, right? Okay. So post tagging is done. Still named entity relationship is not done. Right? Named entity recognition and TF-IDF and also levertization is pending. Okay, we'll do that. And then I'll show the same thing with Spacey and then I'll explain the Rubik's algorithm. Okay. So it's taking time to download. Eva heading out recognition. Just developing more next week. First, let me explain how to deploy so that you can start deploying to your old project so it becomes an end-to-end. Okay, so I want you people to install VS Code and learn how to set an environment as well as how to install Streamlit. So when I say named entity relationship, so I'll be using from NLTK. Just import any chunk. Okay, this was the library we'll be using. And then you have to take a text. Let me take it like John is working at Google company as HR in Bangalore. Okay, let's see, this is my test. So before we apply anything, it's very much important to do what? word tokenization, right? Let's perform a word tokenization. I'll say words equals word tokenize, and you'll be passing your text. And then you have to create a post tagging as well, and then that post tagging has to be sent to the any chunk. Okay, just call tag equals, call your post tag. It's already imported, so I'm not calling it again. So just pass your words, and then you have to find NER. So NER equals, just call your any chunk, and then you just need to pass your tag. Okay, finally, let's try to print NER. Sorry, it's a post tag, not a post. Can you see? John is a noun. It's a person, sorry. It's recognizing like a person. And then Google is an organization. By default, HR also recognized like a organization, and Bangalore, it's a location. So this is how the named entity recognition is going to work. It is just identifying the specific things. Clear? Understood? Done? If I give a heading as TF-IDF, TF-IDF in the sense it's a term frequency and inverse document frequency. Already explained like how it works. So implementation is very simple. This is not available in NLTK. It's a sklearn library feature. So just call from sklearn dot feature extraction dot text. Let's import. What shall we import? TF-IDF, a TF-IDF vectorizer. Okay, done. Okay. And then I'm going to take a sentences. So let's say if you have sentences, something like this. First sentence is Python is easy. Next one is SQL is hard. Next sentence is both Python and SQL is easy. Okay. Now you just need to call your TF-IDF. It's like a model. It's like a model. So now you have to do a fit transform. You have to pass all your sentences. So I'll be just calling x equals. So call your TF dot fit underscore transform and just pass all your sentence. Well done. You want to see like which features it has taken? You can just call your TF dot get feature names out. See? So basically it has taken all, like stopwords are not removed, taking everything. Python is a both and everything. So if you don't want to take a stopwords, you can just remove them and then you can perform a TF-IDF. Okay. So now if you want to see like how it has converted, you can just call x dot to underscore array, wherein you'll see now matrix format. Why x is not defined? It's a capital X, sorry. To array. Okay, it's not an underscore, just a to array, like this. This is how TF-IDF is going to work. This is how TF-IDF will work. Done. Yeah. So one more is left out, which is a lemmatization. So for just give a heading as lemmatization. So from nltk.stem, just import wordnet lemmatization. And then let me just initialize this. You can actually apply individually as well, such as like, let's say, for example, playing, study better, something like that. So just call your lemmatizer and just call lemmatize. Le dot lemmatize. And let's see, I'm going to pass running, okay? Let's see what it will give. It's giving running only. For studying, it's giving study only, right? For better, it's giving better only. You know why? You know why it's giving the same thing? Because it's not understanding the parts of speech. Okay, we have understood that lemmatization works only with a part of speech. So for that, what you can do, you just import from nltk.corpus the wordnet. Okay, so in order to define a part of speech, so from nltk.corpus, just import a wordnet. So then you have to define that particular part of speech. So how do you define? So just say pos equals wordnet dot. If it's a verb, just say like a word. So pos dot wordnet. No, pos equals wordnet dot. Don't you think running is a verb? So it gives a run. Okay, even studying is also a verb, right? So it's a study, giving correctly. So coming to a better, what kind of part of speech is better? Adjective or adverb? Adjective? So just give ADG. Yeah. Got it how lemmatization works? Got it how lemmatization works? Any questions? You are done. Let me show you one more bag of words. Bag of words as well as this n-gram in this only, then I'll show with a spacey. So, bag of words. So, bag of words is also called as a count vectorizer. Count vectorizer, just try to find the frequency of the count. I mean, frequency of a word, like how many times word is repeated. So, from a scale on dot, so it's feature selection or feature extraction. So it's a feature extraction. Dot text. You just need to import count vectorizer. Okay. And I'll just call CV equals count vectorizer, just initialize it. And then you have to take a text. So text equals, or you can just call let's say I'm taking 2 sentences, Python is easy. Python is hard. Okay. So x equals CV dot fit underscore transform. You just need to pass your CV. It's not iterable. Oh, what I'm passing, sorry. I need to pass a text. Done. Then if you want to see, it should be x CV dot. First, let me see the features. Get features name out. Okay. And then I just want to see like how it has done the converting. Can you see? First sentence it 1011. For second sentence it is 011. If you are making a single sentence, you will get like this. It is counting the frequency of a word. Cleared. Understood. Any questions? Hope it's clear. Okay, next one. I'll show like how n-gram is going to work. Take the same thing, okay? And you just need to add like how many words it has to take. That's an n-gram. Let's say for unigram, I'll just give n-gram range equals 1, 1. Okay. Just see like how it is going to take a words. It will take one word. This is unigram. Okay, what happens with a bigram? Let me show. Take a same code. and change your range to 2,2. Can you say it's taking 2 words? Get it? This is bigram. For trigram, it will take 3 words. You can try. You can try. Just see like how it's taking 3 words. It's done, clear. Okay, let me show you same thing like how it happens with a spacey. Spacey is another library which was basically used to deal with your so NLP text cleaning. Okay. So first you have to import certain libraries like pip install, spacey, Gensum, and scikit-learn. Exclamatory pip install, spacey, Gensum, and if you want, you can also import scikit-learn. So import all these libraries. And we'll be downloading one of the spacey model called as Encore WebSM. Just download this. First you have to install, then you have to import it. Import species, import. Okay, sorry. And then just import model equals. It's a species dot load. Load this model. First, I'll show you the word tokenization. So when I say word tokenization, very simple. Call your text. I'll say NLP is easy. Just pass your text into a model. Okay. Pass your text into a model and then just use X for X in words. Done. Word tokenization is done. So this N4 WebSM model has all the processing steps. In NLTK explicitly you use a libraries, but here only one model can do all this. Hope it's working.
Yes, ma'am.
Next one, sentence tokenization. So we'll take a same text, okay? I'll call it like sentences. So basically what happens here, X for X in sentences will give you word tokenization, but you want a sentence tokenization. No? So basically you have to pass two sentences. One is NLP is easy, Python is hard something. Okay. Look here, by default, it's giving you a word tokenization, right? But if you want a sentences, just use sentences dot send. Okay, and then you have to call, sorry, it's a sense. So now you have to call x dot text. Simply. See, you got a sentence tokenization. Next, we'll go to stopwatch. NLP is very easy and interesting. So, you need word tokenization, just pass into your model of text. So X for X and words. So we have to remove the stopwords now. So we have to print words only if it's not a stopword. So for that, I just write a logic right. Logic like, if not, if X is not in stopwatch. So X dot is stop. Can you see? If you want, you can give an X dot text as well. Without that also, it gives you the same result. You will get in a list, codes will be visible if you call a text. That's how you remove the stopwords. Simple. In the spaces, stemming is not possible, only lemmatization is possible, but to a simple way. I'm taking this text. Okay. So what's equals, I'm just passing it to a model. Okay. Then you have to apply the lemmatization. Very simple. X for X in words. So for each word, you just need to find a lemmatization. Just use dot lemma. Can you see? That's so simple. Done. Next one, pause tagging. So I have started studying NLP and it's very interesting. Just pass your text into a model. See here, no need to import things and all. Directly you can do it. Here basically I want to reference a word as well, okay? So instead of using a list comprehension, I'll be using a if you don't want stopwords and all, you can see like if not. So I'll be using only for these. I want to know the part of speech, just call, not a pause. So it's X dot. Can you say you got a word as well as corresponding part of speech? Easy, right? Compare to your NLTK. Yeah. So for any R, just take any R text. So basically, stop word not required here. Without that also, if you say like entities, words dot entities, it will recognize only the entities in your important things are what in this John, Google, and a Bangalore, right? So I want to know what kind of entity is that. So simple. You can just call x colon x dot label underscore. Very simple. Look, it's recognizing it wrong. Bangalore, it says like a person. Yeah, it happens sometimes. It's not recognizing a Bangalore.
Ma'am, that is because of the name, like you have to give Bengaluru.
It was recognizing.
Yes, ma'am.
Mm, yeah, because model will be updated with the current name, right? So instead of Bangalore, we call it like a Bengaluru. Yeah. But this is better compared to your NLTK, giving properly. Person, organization, GP in the sense it's like a geographical thing. Cleared, understood. So this is all about a text query. Next we'll start with Naibesh. I'll explain what is it and how it works. And also, if possible, we'll do the implementation. Let's take a quick break. 10:17, just take it till 10:25. Okay. So people are back. You can see my screen. Yeah.
I'm getting blur.
Yeah,
Your voice is low.
just give me a minute. Check now. Is it visible?
Yes, ma'am.
Okay, am I audible properly?
Yes, ma'am.
All right. So now I'll be discussing about, the first algorithm that basically comes under NLP. That is, in order to deal with that text, is basically uh, naive Bayes. Okay, it's a part of machine learning as well. So I'll show you like how it's going to work. So it's naive Bayes. Again, even it comes under a supervised learning. Comes under supervised learning, which requires basically both input as well as an output. Second important thing is it is mostly used for a classification. Most of the time, we use it for a classification task itself, for classifying a text. And third important thing, so naive Bayes assumes that the relationship between, or assumes that there should be independence there should be independence among input variables. So what do you understand from this? People can ask you what is the assumption of naive Bayes. The very important thing, when you have a data, you will have an n number of input variables will be there, right? So among those input variables, there should be independence. There should not be dependency. Okay, there should not be dependency. We call them like a, there should be independent. They are all different. No relationship between any two variables. So that's what we call it like a assumption of a naive Bayes. Okay. So now, how this naive Bayes is going to work? So basically, in the name itself, it says that naive in the sense are independence. So it will be using a concept called as naive Bayes theorem concept. So you might have heard about in statistics, there is a concept called as a Bayes theorem. Are you aware of Bayes theorem? Are you aware of Bayes theorem? So it will be using a concept of Bayes theorem in order to deal with this particular algorithm. Okay, so most of the time this algorithm is used for major purposes like for email classification. And also it can be used to solve sentiment analysis. So when I say sentiment analysis, like classifying whether a review is positive or negative, mail classifying it like a spam or a ham. Okay, for all these tasks, we'll be using this Bayes. And first, let's understand what is Bayes theorem, and I'll show like how it works. So you'll not understand much when you look into the Bayes theorem. So it uses a Bayes equation, okay? So which is probability of C given X equals probability of X given C, probability of C divided by probability of X. This is the formula. So here understand X is an input, C is a class, that is a target variable. Okay, so here, so P of X represents like a probability of a predictor variable. So we call it like a predictor prior probability. You will understand better when I show an example. Predictor prior probability, that is a probability of your input variable. Probability of C in the sense C stands for a class, the target variable. So this is going to be the class prior probability. And then we have probability of X given C in the sense posterior probability. Sorry, it's a probability of a predictor for a given class. Okay. So probability, what is the probability of X? We call it like predictor. So it's a probability of a predictor for given C. Okay. And then, so probability of C given X. This is X, okay. This is what we are trying to find. So what is the probability of class for given input? It's like, what is the probability that the mail would be spam for a given email? Okay. What is the probability that you can say that mail is a spam for a given email? So it's a probability of a class for given X. For given X in the sense like an input. So that means you have to find this, right? Email is that you have to tell what is the probability of that mail being a ham or a spam. Okay, that's what this formula tells you. You can find it with the help of probability of predictor given C, probability of class, probability of X. If you know them, you can easily make a prediction. Got it? I know you might have not got a proper clarity, but you will understand it with an example. C is a class of a target, and X is an input variable. Just remember that. Done. Okay. So we'll try to understand this particular equation with the help of this data set. So we have our two variables, okay? One is a weather and another one is a play. So basically in this case, you have to predict based on a given weather, you have to predict whether child can play or not. Okay. So first question, what is the probability of playing if weather is sunny? What is the probability of playing when weather is sunny? Okay, so that means like what you have to find. So what is given here? You have to find the probability of class for a given x. So that means you need to find whether a person can play or not when weather is sunny. So for that, find both probability of S given sunny, no given sunny. This is what you have to do it. Understood what is C given X? It's a probability of C given X, S given sunny. If a weather is sunny, can a child play? If weather is sunny, so the child cannot play. Okay, we'll find the probabilities based on whichever has got the highest probabilities, we'll be picking up that. Clear? Understood? So now to answer this, first let me explain the steps and then let's proceed doing the calculations. Okay, like how naive Bayes will work. Let me explain the steps first. All right. So naive Bayes steps, working procedure. Simple. First important thing, we have to convert data to frequency table. Convert data to frequency table. And then so create likelihood table by finding probabilities. Okay. Then use Bayes equation. That is naive Bayes equation. So to find the posterior probability of a class. Okay, then you have to select the class with highest posterior probability and that's going to be the outcome or that's going to be the result. Okay, select the class. Which has got high posterior probability. And that is going to be your what result? Which will be result, which will be the outcome. Okay. Yeah. 4 different steps. I'll show all 4 steps. Done? Understood the steps? Okay. So we'll do the first step, which is finding a frequency table. Okay. When I say frequency table, so you have weather column. Okay. So first step, so we are creating a frequency table. Frequency table in the sense which helps you in finding the count of each one. So I'll be taking a weather. So what are the different weather you have? So you have sunny, you have rainy, and then you have overcast. Okay, and this, let me make it a total. And how many targets we have? 2 targets, right? One is S, another one is a no. So now tell me how many sunny combination, how many sunny yes, how many sunny no, how many rainy yes, rainy no, how many overcast yes, how many overcast no. So that's a frequency table. Count and tell.
5 yes and 2 no's for Sunny.
Okay, good. Then rainy, 1, sure, 1, 2, 2 yes, 3 no, 3.
Yes, ma'am. 2 yes and 3 no's.
Opposite. Mm. Overcast, 1, 2, 3, 4, 5. 5, 0. Total 10, 17 should be there, yeah. And the total S's, we have a 12, total no S, we have a 5, and total observations, we have a 70. Okay, this is our frequency table. Second one is likelihood table. Finish this frequency first. Likelihood in the sense finding probabilities now. Oh, done? Okay. So now probabilities. Can you tell me what is the probability of S?
మిక్సర్ చక్కగా
So what is the probability of S? Shravani, please. Yeah.
పోతానులే తనకి
Probability of S is what? 12 by 5. Total S is 12 divided by total observation is 17. Probability of no is 5 by 17. Clear? Now, what is probability of sunny? What is probability of rainy? What is the probability of overcast?
ఏ అంశం నేను సిమెంట్ అట్లా ఉందా అంశం అట్లా ఉండాలి ఓ ఇదే ఇట్లా సట్టుగా
Guys, done. So probability of sunny is basically what? Just a minute, let me share screen by muting her.
ఇది ప్రెస్ చేసేది అంతా చేసిండ పక్క
Sir, can you mute her? I don't have an option.
పోయి ఆకలి కొట్టుకుంటున్నా నాకేం
Shravani,
కన్సర్న్
can you hear me?
చెప్పు ఇట్నా అందరు నిలిపిస్తుంది ఇవ్వండి నువ్వు మరి ఏం అల్లాడతాడు ఉందా ఓకే ఎత్తుకో పలకడుద్దాం చెయ్యి బాగుంది భయన్న ఎక్కడన్నా అక్కడ పోయి ఆడిపోయేట్లు కడుక్కోవాలా నెల్లి మంచి కడుక్కుంటాను వద్దా నెల్లిలో కడుక్కుంటే ఎగరేదా ఎగరేలేదు వస్తానన్నా మంచి ఆబ్సెషన్ దీనిలో పట్టుకో ఓ ఇంకా ఆబ్సెషన్ దిగమ్మ పడిపోతావు కిందకి దిగు కిందకి మంచి డబ్బు వస్తుంది బుద్ధి కిందకి రా కిందకి రా పోయి ముందుకు పోరా అడే ఉండు చేతులు పని పోషిడే ఇంకా కదా సారీ ఫోన్
I don't have an access to share. Guys, we'll do remaining in our next class. Sorry, they're not responding.
మా మమ్మీ నా డ్రెస్ అనుకో
నీకేనా
Okay, thank you. Thanks for joining. We'll finish this. How to do it, I'll show it again on Monday, and also we'll do the implementation. Okay, thank you.
Thank you, ma'am.
ರಾಕೇಶ್ ಶಿಕ್ಷಣಕ್ಕೆ ಯಾರು ಅಂದ್ರೆ
ನಾವು ಗಾಡಿ ತಗೋಣ
ಫಸ್ಟ್
బాగుందమ్మా.
తీసుకోవట్లా ఇచ్చుకోపి ఉండికి
పాసా
ఇప్పుడు వేరే దానికి ఏమో ముక్క
పాస్ అయ్యింది చెప్పండి.
డిస్టింక్షన్
ನೀರು ಪ್ರಸಾದ ಮಾಡ್ತಿರ್ತಾರೆ ತಗಕ್ಕೈನ ఇక్కడ బస్ క్యాన్సిల్ అయిపోయా వచ్చాము అనేసి ಚೆನ್ನಾಗಿ
ಯಾವ ಬಂದಿದೆ ಅವಳು ಕುಪ್ಪಕ್ಕೋರೆ ಬೇರೆ ಕುಪ್ಪನೆ ಇವನು ಅಡಗ್ತಾನೆ
ಕೇಳಿಲ್ಲ ಬೀಳ್ತಲೇ ಇತ್ತು ಅವಾಗ ಯಾಕೆ ಕುತ್ಕೊಂಡಿದ್ರು ಅವ್ರು ಆಮೇಲೆ ಹಾಕಿಲ್ಲ ಹಂಗಿಲ್ಲ ಅಲ್ಲಿ ಕುತ್ಕೊಂಡ ಎದ್ರೆ ಮಾತ್ರ ಯಾರು ಏನು ಕೇಳಿಲ್ಲ. ನಿಮ್ ಮಕ್ಳಕ್ಕ ಚಿಕ್ಕವನ್ ಬಂದಿದ್ ನೋಡ್ಲಿ ದೊಡ್ಡವನ್ ಹೋಗ್ಬಿಟ್ಟು ಚಿಕ್ಕ ನಾಳೆ ಬರ್ತಾನೆ. ನಾಳೆ ಬಂತಿರ್ಬೋದು ಊರಾಗಿರೋದು